Good morning, students. Today we are going to solve question 5 from GATE CSE 2023. The question states that looking at the surface of a smooth 3D object from the outside, which one of the following options is true? This is a 1-mark question and also it is a MCQ, so only one option will be correct, right? They are telling us that looking at a surface of a 3-dimensional smooth object, right? Smooth object from the outside, which one of the following options can be true? What does it mean for the term smooth? The word smooth means having an even or regular surface free from perceptible projections, right? Lumps or indentations, right? So that basically perceptible projections mean that if you were to take your hand and were to place it across it and slide across that surface, then there would be no bumps on that. There would be no perceptible bumps, right? That is what we call smoothness, right? So if there is a bump of this sort, that is not smooth, right? This could be a point or this could even be a line of this sort, right? Yes, this line, this edge being present would mean that the object is not smooth, right? That is what smooth means, and they are asking us in the 3D context, right? Very good, very well understood question. Understanding the question is half the answer. We have understood the question. Now let's read the statements which we have to validate. The first statement reads, the surface of the object must be concave everywhere. What does concave mean? And here convex is also used. What does concave and convex means? In 11th and 12th in physics, there was this concept of concave and convex lenses, right? So that concept I will basically remind you. So this kind of lens is your concave lens, while this kind of lens, right, this kind of lens is your convex lens, right? So now what does concave mean? Concave basically means something that is bent inwards, right? So now they are asking us, the first statement, they're telling us that the surface of the object must be concave everywhere, right? If it is smooth and 3D, then it must be concave everywhere. Is it even possible for an object to be concave everywhere? Not really. And this is something that you would have to imagine, but I cannot help you with that imagination in your mind, but I can give you computer graphics to represent that, right? So suppose that this thing, right, this thing is a normal sphere, right? This is a normal sphere which you can rotate, like, so it is a normal sphere which you can rotate. Now with the help of computer graphics, if I were to introduce a kind of black hole sort of effect, which is software basically helps me with, right, and this is the point at which the black hole is present, which is attracting the particles of this sphere, right? If I were to place it at the center, at the origin of the sphere, all of the particles of the sphere would be pushed inwards, right? That is what concave means, something that is bent inwards, right? So if I were to place it at the origin of this sphere, it becomes a point, right? So an object which is concave at every point and it is a 3D object, then that would become a point, right? That would become a point. So this assumption, smooth 3D object, does not mean that it is a point, right? So this statement that the object must be concave everywhere is simply not true, right? So we can eliminate this statement. The second statement says the surface of the object must be convex everywhere. What does convex everywhere means? Is there an example of this sort? Convex at every single point, that is protruding outwards at every single point. For that, first look at this capsule, right? If you were to look at this capsule, this region, this top region and this bottom region are protruding outwards, so those parts are convex. But this region, right, this region of the sphere, it is not protruding outwards, right? So it is not convex. So this kind of shape has regions which are convex, but they are not convex at every single point. Now look at this. This is a normal sphere. A sphere is a 3D object which is convex, which is protruding outwards at every single point, right? So that means that for an object to be convex at every single point, it must be a sphere, right? Now let's get back here. They are saying that the surface of the object must be convex everywhere, must be convex. So it must be. So They are saying that the simple assumption that it is a smooth 3D object would directly conclude us to this statement that every single point is convex. That means it is a sphere. No, that is simply not true, because a smooth 3D object need not necessarily be a sphere. It could even be a capsule, as it is present over here, right? So this is not true. Okay. The third statement says that the surface of the object must be concave in some places and convex in other places. Now that is a assumption which is, first of all, it is reasonable. It is not very tight. It is not saying it must be like this, it must be like this. It has some flexibility to it. It is more general because it says maybe, right? And it says that it can be concave at some places and convex at some places, right? All of these surfaces which are smooth, this one, right, they are convex at certain regions, and they do not have concave regions, I know, but still they are smooth, right, all these three. So this third statement seems to be true. Now let's look at the fourth statement. The object can have edges but no corners. So object can have edges, right? So basically this object has an edge over here, right? This object has an edge over here, right? That means, see, over here there's an edge, right? This edge does not mean that it is a smooth, right? It cannot be smooth because it has an edge. It is the same thing which I told over here. It has an edge on which if you were to roll your hand like this, you're going to feel this bump, right? This sharp bump right over here, right? So it is not smooth, right? So if it is smooth, it cannot have edges. So this statement is clearly and very simply false. So let's mark it as such. Then the only option is C, which even in our analysis seemed to be true. So now we can say conclusively that yes, option C is correct, right? And it's a very simple question, and obviously it requires a bit of imagination and a bit of confidence in your imagination. That is why I showed all this in a computer graphics manner, so that if you face similar questions in the future and you do a proper analysis, even if you do your imagination, you would have the validation from not my end but in general from this computer graphics that I showed, that yes, it would be this way, right? I hope it adds some value to you, and with that I would like to say have a good day. Like and subscribe if you like the video, and have a good day.